My dear friends, welcome to ACE online platform. A very good evening to all of you. Now, I am here to deal with your environmental engineering subject for your RRB JE CBT-II. See, before starting this session, let me give you a brief introduction about this session, how this session helps you for your upcoming examination, that is CBT-II by RRB JE, right. See, in this 1 hour session, the content I am going to deliver in this 1 hour session will definitely helps you in such a way that as you have already prepared about this environmental engineering subject for your CBT-II, now after revising all the PYQs, as this session is about revision through PYQs, right. As I revised all the previous year questions of your CBT-II for environmental engineering, I have taken the questions in such a way that you can have the maximum revision out of this session, so that it will be very helpful for you, even though you have not taken the subject for your regular preparation as of now. Since even you attend this session, even you definitely get some good score from this environmental engineering subject. Okay. Now, let us dive into this actual environmental engineering subject. See, let us look at the syllabus of this particular subject mentioned in your RRB JE, right. For CBT-II, they have given this, the small piece of syllabus for environmental engineering, right. This is what syllabus: environmental pollution and control, public water supply, domestic sewage, solid waste management, environmental sanitation as well as plumbing, they have mentioned as syllabus for this particular examination. See, I have categorized, I have divided this given syllabus into various chapters. Let us look at that. See, these are all various chapters I have taken, right. If you can look at this, environmental engineering is broadly water supply engineering, wastewater engineering as well as solid waste management, air pollution and noise pollution, right. These are all various chapters we are going to cover in this session. I have considered the questions in such a way that I have to cover the each and every chapter mentioned in this slide, right. Okay. Before getting into the actual question analysis through revision through this PYQs, let me tell you this weightage, right. This is an important aspect for any competitive exam. If you can look at the weightage, let me see, the weightage is around 5 to 6 marks. This weightage is 5 to 6 marks is weightage for this particular subject. See, you may think weightage is little less, but out of 100 in a technical subject, as you all know, CBT-II is having 150 marks paper, out of which 100 is for technical abilities and 50 marks for non-technical, right. In that 100 marks, 5 to 6 marks is a considerable weightage. It is not least subject you may think, right. 5 to 6, that too, this environmental engineering subject is easily scoring. You can easily scoring 6 out of 6 marks from this particular subject. So that if you take this 1 hour session seriously, definitely I can assure you, you will get 6 out of 6 marks from this particular environmental engineering subject. Okay. Okay, let us start the actual PYQs now. Okay. Look at this particular question, very easy. Try to answer, my dear friends. Just reply if you know this answer. See, this question is the prescribed per capita water demand for small cities and towns is. What is the water demand? Prescribed per capita water demand for small cities and towns. This is indirectly he is asking about domestic water demand for small cities and Indian towns, right. That is what? 135 liters per capita per day. This is very easy. The one of the standard question in all competitive exams. The domestic water demand is 135 LPCD, right. See, let us discuss briefly about it so that you can have some idea about domestic demand. See, look at it. As per IS 1172/1993, this is a water requirement code. As per this code, domestic requirement is 200 LPCD for a full flushing system. For weaker sections, it is 135 LPCD. This is what given by this particular code. That code is what? IS 1172/1993. Remember this code also, they may ask you sometimes. the water requirement code is IS 1172/1993. As per this code, we have this data regarding this water demand. See, if you can look at this domestic water consumption, this is the major contribution in all water demands. It is around 50 to 60% of the total demand. Only domestic water demand contribution is 50 to 60, means more than half of the water demand is by domestic only. Again, I am giving this point not to remember, but it will help you to the next questions. Okay. See, IS code has laid down, that IS 1172/1993 has laid down a limit on the domestic water consumption between 135 to 225 LPCD. This is the domestic water demand limit he has mentioned, not the single value. There may be a variable domestic water demand, but between these values 135 to 225, right. With this you can answer some additional questions. With full flushing system is 200, weaker sections is 135, right. Okay, the next question is, the average water consumption for government offices ranges from, look at this, what is this government offices? Institutional and commercial water demand. What is the average water consumption for government offices? It is 45 to 90 liters per capita per day. I think somebody is answering, right? Okay, Yakesh. Okay, good. Okay, next look at this. We have a little discussion about commercial and institutional demand. Okay, if you can look at this table, you may be worried about the lots of data given in this table, right? But don't worry, let me help you how to remember this table. At least a few contents in this table can be easily remembered. If you can look at this, you remember only for offices, which is what? 45 to 90 for offices. That value again you can apply for day scholar schools, that is same as 45 to 90. You can see in the schools, residential schools as well as nurses homes and medical quarters, we have 135 to 225. If you can relate this information, you can easily able to answer these questions, right. Here in this question, offices value is has asked, that is 45 to 90 LPCD, which is same as day scholar schools. Now for residential schools and nurses homes and medical quarters, 135 to 225. You can remember these four values out of many values, right. See, 135 to 225, just now we discussed domestic demand, the code has laid down a limit from 135 to 225, that same as this nurses homes and medical quarters as well as residential schools, 135 to 225, like that. You can remember at least not entire table, some data you can able to remember, right, with some correlation. Now the next question, identify the National Board of Fire underwriters formula for the estimation of fire demand for a firefighting purpose in urban areas from the following. They have given these four options for this fire demand. What is the formula he is asking? National Board of Fire underwriters formula. Which one is your option, right? Option, tell me. National Board of Fire underwriters formula, that is option C, right. 4637 root P 1 minus 0.01 root P is the National Board of Fire underwriters formula. If you can look at the other options also, 3182 is the Kuchling formula, 5663 is Buston formula. This one is Freeman formula, but given as wrong. 1136 is correct, but that is the option given, right. But here the question is option C. If you can look at the fire demand, quickly revise what are the various fire demand formulae. We have Kuchling 3182 root P, we have Buston formula 5663 root P, Freeman is 1136 P by 5 plus 10, and National Board of Fire underwriters formula is this formula. That is what the question is, right. This is all about the fire demand. Let us have a quick revision with the help of previous year question asked in your RRB JE, right. This is the quick recap of all fire demand formulae. Okay. Try to participate, my dear friends. Okay, the next question is, the water distribution networks are normally designed for a period of, what are the design period for water distribution network? This is a very easy question, that water distribution networks are designed for the design period of 30 years, right. The design period is what? 30 years. Okay, if you can go through this table, you can easily remember this data. Let me help you, right. See, these are all various items, means there are various components in the water supply scheme and the corresponding design period in years, right? Forget about dams, they are huge structures, this design period is very high, that is 50, dams design period is 50. Look at the other data, it is either 50 or 30. If you can look at 15 values, see if you can look at this, electric motors and pumps, water treatment units, as well as service reservoirs, overhead reservoirs or ground level reservoirs, all those values, all those units are having design period of 15. Why they are having 15? Whenever we need a maintenance and repair of certain unit, those design period is relatively lesser. See, if you can look at the electric motor and pump needs maintenance, treatment units, you have a sedimentation, coagulation unit, filtration unit, all these units requires maintenance. Whenever maintenance is needed, we need to replace that component as early as possible. That's why it has given 15 years as a design period. You can see reservoir needs also maintenance, right? It is 15. Remaining all are 30. If you take intake, if you construct an intake structure, it has to cater the demand for 30 years. That is what design period, right? Next, pipe connections to the several treatment connections also, like joints, we need to design for 30 years. Raw water and clear water conveying units means pipes are also 30, distribution system is also for 30, right? This is all various design periods for components in a water supply scheme. You can easily remember dams is 50, remaining are 15 or 30. You can easily remember 15 value, since the maintenance is needed for certain units in the water supply scheme, those are 15 and remaining are 30. Easy to remember this table also, right? With a small question, we can have many number of questions can be attempted if they ask you in a actual exam, right? That is what my intention to take such a questions, okay? Okay, next question, which of the following population forecasting method estimates highest value of future population, which is having the highest forecasted population among the given options, that is geometric increase method. Option B is correct, right? You all studied arithmetic, geometric, incremental increase, decreasing rate of growth method, right? This geometric increase method estimates highest forecasted population. Least value can be given by arithmetic increase method. The value which can be given by incremental increase is anywhere between arithmetic and geometric increase method, right? Okay, if you can look at these various methods of population forecasting and the criteria of this, you can easily recall this from your memory, right? See, where you apply arithmetic increase method for old and settled communities, where you apply geometric increase method, geometric increase applied for young and rapidly emerging cities, right? Young and rapidly expanding cities. The next one, where you apply incremental increase method, which is applied whether the city is old or new, you can adopt this method of population forecasting. Decreasing rate of growth method is applied whenever the population shows the downward trend, then you can go for this decreasing rate of growth method. Quickly you can able to recap these information about various population forecasting methods, right? Okay, the next one, which of the following is taken as hourly variation factor? Here you must be very careful, don't be in a hurry to answer these kind of questions, okay? Which of the following is taken as hourly variation factor? Which is hourly variation factor? There is no 2.7 in your options, right? You may think hourly demand is 2.7 Q, but he is asking hourly variation factor. See, you know, all of you are knowing maximum daily demand of the maximum day is Q max hourly, right? This is the maximum hourly demand of the maximum day is what? Q max hourly demand. If you can decode this Q max hourly, generally it is 1.5 times of average demand of the maximum day, average demand of the maximum day. See, 1.5 times of average hourly demand means maximum daily by 24. Total daily demand divided by 24 hours will give you average hourly demand of that maximum day. Therefore, 1.5 times maximum daily. You know, maximum daily is 1.8 Q divided by 24. If you multiply these two, you will get 2.7 times average hourly demand. But he is not asking this factor. You may confuse here. He is not asking this factor 2.7. He is asking hourly variation factor is what he is asking. This hourly variation factor means the average hourly demand of the maximum day is varying 1.5 times, means 150% of the times this value is varying. That is what? Hourly variation factor. Your answer could be what? Your answer could be 1.5. Option A is correct, not 2.7, right? Remember that, very very important value. Many times asked the hourly variation factor in many competitive exams, okay? Not 2.7, even though they have not given 2.7 in the questions, in the options, right? Okay, the next question is, okay, let me take a quickly what are the various values of demands, right? Okay, let me take, these are maximum demands that you have studied, these are peak factors. You all know these peak factors are known as Goodrich peak factors, right? These peak factors are known as Goodrich peak factors. Okay, can anybody answer this? Goodrich peak factors. What are Goodrich peak factors? Maximum hourly demand of the maximum day is how much? 2.7. Maximum daily is 1.8, weekly is 1.48, monthly is 1.28. See, if you can able to see these factors carefully, with increase of time, hourly, daily, monthly, weekly, factor is decreasing. You can look at the value of factor here. The factor value is decreasing from 2.7 to 1.28, right? Maximum daily, maximum hourly is 2.7, daily is 1.8, weekly, sorry, monthly, weekly is 1.48, monthly is 1.28. If you increase the time period, the factor value is decreasing. Likewise, you can remember this Goodrich peak factors. They may ask you peak factors, right? See, this maximum hourly demand of the maximum day is also known as peak demand. This demand is known as peak demand. This is peak demand. Sometimes they may ask you what is peak demand. Simply you can say maximum hourly demand of the maximum day. Okay, the next question is, the suspended solids present in the surface water can be determined by, you know, suspended solids are they are of more than the specific gravity. Its specific gravity is more than that of water. They are removed by gravity, right? You all studied this. How can we estimate its presence? How can we determine the presence of suspended solids? Suspended solids can be determined by gravimetric method. The method is option A, gravimetric method. Okay. If you can recall very few some water quality parameters and the corresponding method of measurement, you can quickly recall this, right? Property of water and test or instrument with which we can measure that property. What is hardness measuring? By which method? Hardness is measured by EDTA method or Versenate method. What is the method of measurement of DO? What is the titration test is known as Winkler's method. DO is by Winkler's method. Chlorides is by Moore's method. What is the pH? pH is by potentiometer technique. Color is by tintometer, is a device which measures the color, as well as Nessler's tubes. They may ask you sometimes, color is measured with a device called tintometer. Nessler's tubes are also measures color of the water. Taste and odor can be measured by device called osmoscope. Taste and odor is by osmoscope. Turbidity can be measured by turbidity meter, turbidity rod, as well as nephelometer, right? We studied various turbidity measuring devices which works on the light scattering as well as light absorption, right? Look at the devices: turbidity rod, turbidity meter and nephelometer. This turbidity rod and turbidimeter works on the principle of light absorption, but this nephelometer works on the principle of light scattering, right? Okay, now bacteria count. Bacteria count can be expressed in MPN, right? Most probable number test, MPN test, right? Try to answer these questions, my dear. MPN test. Okay, you can able to recall this from your memory quickly with the help of a small PYQ, right? Okay, now look at this very interesting question. Sometimes students may confuse here. See, the hardness that is equivalent to alkalinity is known as what is asking, the hardness that is equivalent to alkalinity. What is that kind of hardness which is equivalent to the alkalinity of water? See, if you can able to recall, you can answer this question very easily. You know this, right? What is the carbonate hardness? Carbonate hardness is the minimum of total hardness as well as total alkalinity. Whichever is minimum, that value is equal to what? Carbonate hardness. Therefore, if the carbonate hardness is equal to the alkalinity, it will be a possibility, right? Out of this hardness and alkalinity, whichever is minimum which is equal to the carbonate hardness, here in this question the hardness which is equivalent to alkalinity, that is what? If it is equivalent to alkalinity, that hardness we call it as carbonate hardness, right? If the alkalinity which is equal to this, what is that hardness called? Carbonate hardness. The very easy question. The answer for this question is what? The hardness that is equivalent to the alkalinity is known as carbonate hardness. Option B is correct. Okay, try to answer, my dear friends. Okay, the next question. These are very important area in the quality control of water. If you can look at this very easy question, the waterborne disease poliomyelitis is caused by, this poliomyelitis is a viral, right? Viral disease. Therefore, the answer for this question is virus, right? Let me give you the quick recap about this waterborne diseases. We have list of waterborne diseases: typhoid, cholera, polio, jaundice and dysentery, right? See, the typhoid and cholera are due to bacteria. These are all bacterial diseases. Polio, jaundice are viral diseases. Dysentery is from protozoal disease, right? If you can segregate these diseases given in this list, you can able to answer a few more questions asked in the competitive exams, right? Typhoid and cholera by bacteria, polio, jaundice by viral, dysentery is by protozoa. If you can, they may sometimes ask you the specific microorganisms name also. Here, let me provide you that also, name of microorganism. See, typhoid is by Salmonella typhi, right? And cholera is by Vibrio cholera. Polio is by poliomyelitis, that is the virus in this question. Jaundice is hepatitis virus. Dysentery is Entamoeba histolytica, that is the protozoa name which causes dysentery disease, right? With this list, you can able to answer the variety of waterborne diseases and the corresponding classification and the corresponding organism name, right? Very easy to recall this. You have already studied waterborne diseases, right? Okay, the next question. Look at this. The total coliform bacteria are reported as most probable number. He is asking the total coliform bacteria, we usually report its count in most probable number as well as E. coli index. Now, we report MPN per 100 ml, per 1 liter, per 1 ml, per 10 ml. What is your answer? See, we report MPN usually for 100 ml of water, as IS code is specifying as IS 10500 and 2012, there shall not be any bacterial count detectable in a drinking water quality, drinking water. That is what given by the code. MPN is 0 per 100 ml. If you take 100 ml of water sample, it cannot be detected by any bacterial load, right? That is what given, 100 ml we needs to take, that is the standard. Now, look at this. What is the fluoride ion for an optimal dental health? Fluoride ion for an optimal dental health. See, for a good dental, it prevents dental cavities in children. That is the fluoride's benefit, right? If you want that dental cavities prevention, you need 1 milligram per liter minimum needed for dental, to prevent dental cavities. For dental health, 1. If it is exceeding 1.5 leads to dental fluorosis, if it exceeds 5, that is bone fluorosis or skeletal fluorosis. Okay. The next question, what is the limit of chloride in drinking water? You know, limit of chloride in drinking water is 250 milligram per liter. These are all various water quality parameters, right? Now, let me take a few seconds to display this water quality parameters given by the Indian standard 10500 and 2012. There may be a chance from the upcoming competitive exams, they may ask you this water quality standards given here, right? Acceptable limit as per this code is this permissible limit in the absence of an alternate source. If you found these kind of wording in the competitive exam, then only take the permissible limit, otherwise don't take this permissible limit, right? They specify in the question itself. They may ask you any of this particular water quality parameter, its permissible limit in the absence of an alternate source, then only you write this limit, otherwise acceptable limit only you needs to give, right? Look at this color TCU 515. Just take a look at these water quality parameters so that you can be thoroughly revise these water quality standards for your upcoming exam. There may be a chance that they may ask you according to this code IS 10500 and 2012. This is what water quality standard code. Okay. Not only this, we have these many parameters. We have hardness, chloride, sulfate, fluoride, you know 1.5, and nitrate also, and metals also. Have a look at these 3 images, will help you a lot. Take a screenshot of this one and this one and this. Okay. This is about water quality parameters. Okay. Now look at this question, very easy question. You may think the given code, you may not aware about this whatever the code given in the question, but without knowing that code, still you can able to answer these kind of questions with your common sense. Look at the question, which type of order characteristic is not used? Remember this, which type is not used for classifying order of a given water sample as per the code? Forget about the given code, you may not aware about the code, it doesn't make any sense, but if you understand what he is asking, order characteristic is not used in classifying the order. Look at the characteristic, degree of pungency. See, pungent means somehow related to order, right? Sweetness, it is related to taste, right? Order and taste we measure together, taste and order, you know, threshold order number, right? This pungency is related to taste, order, sweetness is related to taste, smokiness is somehow related to order and taste, but degree of turbidity is not related to order and taste, that is the light phenomena, right? Turbidity. Therefore, which is not used for classifying the order, with the common sense we can answer this question, option D is correct, right? Pungency, sweetness, smokiness are somehow related to taste and order, but this turbidity is not at all related to taste and order. Therefore, which is not used in classifying is D. Okay. The next question, one turbidity unit NTU is equal to, as we studied, we measure the turbidity with the help of nephelometer and expressed in NTU, nephelometric turbidity unit. Sometimes occasionally we express our turbidity in pharmazine units, that is what, 1 milligram of pharmazine mixed in 1 liter of distilled water, that is FTU. Sometimes this NTU expressed in pharmazine turbidity unit, FTU, which is the option, 1 turbidity unit is equal to what, 1 milligram per liter of pharmazine, right? This is not a silica, silica is JTU, not NTU. If you can go through these things quickly, this is the water quality parameter, standard of measurement. If you know, turbidity expressed in JTU means 1 milligram of finely divided silica in 1 liter. 1 milligram of silica in 1 liter means 1 milligram per liter of finely divided silica mixed in 1 liter of distilled water is gives JTU. NTU, we measure the turbidity with nephelometer device which works on the principle of light scattering. We express that in NTU, nephelometric turbidity unit. The next one is FTU. Occasionally we represent this FTU also, turbidity unit, pharmazine polymer in 1 liter. What is the color unit? We mix platinum as a chloroplatinate ion, right? That is what, true color unit. With this you can quickly revise few concepts of these standards. Okay. Now I have taken this question from noise pollution. This is also an important chapter in this RRB JE. See, this is very easy. When the measured and standard reference pressure level becomes equal, he is saying the measured value as well as standard reference pressure levels become equal, they are both equal, whatever the measured and reference are equal. What is the SPL equivalent to? What is saying in this question, they are saying given value is equal to standard value, measured pressure P equal to P naught, standard reference pressure. This is the given statement in the question. What is standard pressure level in decibel? Standard pressure level in decibel is equal to L equal to 20 log P by P naught base 10. If P equal to P naught, what is the value? Log 1. Log 1 will give you 0. This is 0 decibel. If P becomes P naught, what is that sound pressure level equivalent to? That is 0 decibel. Very easy question, right? 0 decibel. Next question. See, the 20 decibel noise level is how many times more powerful than 1 decibel noise level? See, you may think 20 decibel is 20 times powerful than 1 decibel. It is not correct. Why it is not correct? See, the given what is this pressure levels, the sound pressure levels are on logarithmic scale. You cannot compare a logarithmic scale directly like 1 is 20 times, right? Not like that. 20 times is not correct. See, whenever these kind of questions given, when it involved in logarithmic scale or in exponential terms, you must express in arithmetic words. Then only you can compare. You can divide, you can multiply, you can add or whatever you can do arithmetic operations, but not on the logarithmic scale. You must convert the decibel values into corresponding pressure levels, then only you can say. See, I am converting to compare how many times more powerful or less powerful. We must take those values into consideration. See, I am converting first 1 decibel, okay. I am converting 1 decibel value first, okay. As you know, the sound pressure level, right? Sound pressure level he has given 1 decibel. 1 is equal to 20 into log of P by P naught. P you needs to remember, P you needs to evaluate what is P naught. Standard pressure level is 20 micropascal, right? This is the value. If you can do this, this operation, simple mathematical operation, 10 to the power of 1 by 20 equal to P by 20. Now, what is the corresponding pressure related to 1 decibel? The P will be, P related to 1 decibel is 20 times 10 to the power of 1 by 20. See, 10 to the power of 1 by 20 is 0.05, right? See, 10 to the power of 0 value is 1, 10 to the power of 1 is 10, it between 1 to 10, but 10 to the power of 0.5 is root 10, that is 3. Therefore, this value 10 to the power of 0, 10 to the power of 0.0, like that it is moving. You can take that value is close to 1. Therefore, 20 into, I do not know the value of 10 to the power of 0.01, it need not be necessary, but close to 1, but actual value is 1.12. This is the corresponding pressure in micropascal, right? As we studied that logarithmic thing in a noise pollution. If you take the 20 decibel also, let me take the 20 decibel here, 20 decibel I am taking 20 decibel, 20 equal to 20 log P by 20. What is the value? 10 power 1, right? That is what? 20 by 20, 1 only, 10 to the power of 1. Therefore, corresponding pressure for a 20 decibel is how much? Here it is 20 micropascal. Now you can compare, this is an arithmetic thing. Earlier it is a decibel, it involves the logarithmic word, but now you can compare, let me take this is a P1, you can take this is a P2. How many times this P1 and P2? Imagine just one only. Now look at this, is it P 20 by 21, sorry, it is 10 power 1, 10 into 20, you have to multiply there with 10, 20 into 10 is your answer here. I am sorry about this, this is 20 into 10, here it is 10 into 20, right, 10 into 20, look at this, how many times, here only 1, imagine 1, this is 20 into 10, how many times louder than this level, that is 10 times, right. Therefore, the given answer is A, not 20. Based on the decibel value, we may not compare, right. You have to convert that into arithmetic scale. Okay. Okay, the next question is, see, two machines are working in a noisy environment and jointly produce 55 decibel noise level. Jointly they are producing 55. If the environmental noise level is also 55, means the joint level of noise is 55, background noise is also 55, means two sources you can consider 55, 55. Now, the summation of the noise level is, as we know the code, we have two sound levels 55 decibel and 55 decibel. If the difference between these levels is falls in certain range, we have that codes, right. If the difference, what is the difference? What is the difference value? 55 minus 55 will give you 0. If the difference is 0, you need to add 3 to the value. Therefore, the value will become 55 plus 3 will give you what? 58 decibel. The answer is what? 58 decibel. There is a thumb rule, I think you may studied this. The answer for this question is what? 58 decibel. See, look at this thumb rule given. If you go through this table, you can easily answer those kind of questions asked in the noise pollution chapter. See, the difference between the highest and next highest noise level is given in this range. In this earlier question, what is the noise levels given? 55, 50. What is the difference? 0. If the difference falls in this range, you need to add 3 additions, means to the highest level to the estimated total noise level. If the difference is 0 to 1, you need to add 3. If the difference like 56, 58, difference is 2, it is falling in this range 56, let me take that. See, if I give 56 decibel one noise level and 58 decibel is another noise level, what is the difference? The difference is 2, right. If the difference is 2, it falls in this range. What is the addition? This 2 needs to be added to which value? Addition is highest level to the estimated total noise level. Out of 56, 58, highest value is 58. For the 58, you need to add that addition value is 2, since the difference falls in this range 2 to 3. Therefore, 52 plus 58 plus 2 will give you 60 decibel. If two noises, one source is emitting 56, another source is emitting 58, the summation of the noise is not 56, 58 plus, not like that. 60 decibel is correct. The summation, you can hear 60 decibel sound if you can hear the 56 and 58 at the same time. The summation of the noise will be 60. Like that, you can remember the difference in the noise values and the corresponding addition, right. 4 to 9 is if the difference is between this range, you need to add 1 to the highest value. If the difference more than 10, whichever is the maximum that you can take as a summation of the total noise level. If you can take 50 decibel and 70 decibel, what will be the difference here? The difference is 20, more than 10, therefore highest level is total level. Therefore, if you can hear the 50 decibel, 70 decibel simultaneously, the noise you can hear is the summation of the noise will become 70 only. Highest level you have to take if the difference is more than 10. That is what highest value you need to take, right. This is about addition of noise levels. Okay, very easy, important questions. Okay, look at this. This is the very important question, many times asked in your RRB JE and other competitive exams. See, they are focusing more on standards, noise standards. Look at this. The prescribed permissible noise level for residential area at night time, the value is 45. But see, let me give you a beautiful code to remember the data in very better way. You can recall this data when you are in exam, right. Look at this table, noise standards. Please focus here. This is very important. If you able to understand this my method of memorizing these values, so that you can easily recap when you are in examination hall in such a pressure. Okay, try to see this. See, as per the government norms, we have a various zones: industrial zone, commercial zone, residential zone and silence zone. Highly noisy is an industry, then commercial, then residential and then silence zone. This is the noise zones we have as per the norms, right. See here, noise level in decibel, daytime, night time. I need to frame this table first, right. See, let us remember only 75. What is 75? This is golden jubilee, right. If you remember only 75 golden jubilee, you can frame this table. Only one thing you need to do is you must write these zones in order, otherwise the entire table will gone. Okay, you must write industry first, then commercial, residential, silence zone. This is what you need to remember. 75 only you need to remember. See, from the golden jubilee 75, if you deduct 10, you will get all the daytime noise. 10, 65, 10, 55, but the last value 5, that is 50, right? If you want the various zones and the corresponding daytime noise levels, allowable noise levels, from the golden jubilee deduct 10, 10, last value 5. If you want last value, from this value deduct 5, top value is 10. If you want nighttime values, from the same golden jubilee you need to deduct 5 from the top, remaining 10. 75 minus 5 is 70, 65 minus 10 55, 55 minus 10 45, 50 minus 10 40. See, are you getting my point? Only 75 and the zones in the order you must remember. If you remember this 75, then you need to deduct 10 last 5, bottom 5 deduction. This value, if you want bottom 5 you need to deduct. If you want this value, top 5 you need to deduct, bottom 5, top 5. That is what the logic here to frame this table. See, if you are sometimes you are unable to frame these zones in order, I have a code for you, that is Indian core sector, means Indian industrial, core commercial, RE residential, sector mein S, that is silence zone, right? If you are unable to recall these zones in order, you must remember Indian core sector, Indian core sector. You need to write like that, Indian industrial, commercial, residential sector. With this you can frame the table without any confusion. You may think, sir, these are very easy, all are 55, 65, 75, but in an examination hurry you may take these 5s very confusing thing, right? Sometimes you may pick this value, 5s only, right? Very, very confusing. Frequently you may lose marks. If you follow this rule, if you take golden jubilee, you can frame this table effectively, you can easily write. Remember, this is daytime, this is night time. Don't swap also, right? Just have a look, constant observation to this table, so that easily you can attempt questions based on the noise level, right? This is about noise standards. Okay, next, this is the last question in noise level. Okay, see, this is a typical question. So rarely they may ask these kind of concepts. See, an octave band is a frequency band with upper and lower cutoff frequencies having a ratio of. He is asking, what is this octave band first, right? You must understand what is the octave band. See, any noise can be analyzed by framing that noise into corresponding frequencies. If you can break down that noise levels into corresponding frequencies known as a spectra, then only we can analyze the noise levels effectively. See, what is octave band is saying? See, first we must understand the spectra. A noise can be analyzed by breaking it down into its frequency components known as spectra. This octave bands having 8 to 11 bands, 8 to 11 bands, this octave band is having. They may ask you this figure also. Octave band is having 8 to 11 bands. Now, an octave band is the frequency interval between given frequency and twice that frequency. This is what an octave band, given frequency and twice that given frequency. That is what a range, frequency range. See, the lower limit is 44 and 88. If you take 20 to 44, this is what an octave band. In this particular question, what he is asking, look at the given question. In this question, he is asking this value. In this question, an octave band is a frequency band with an upper and lower cutoff frequencies having the ratio. What is that ratio? Ratio, if you can take the ratio as a frequency, twice that the frequency, right? Ratio will give you ratio equal to upper and lower cutoff frequencies ratio is asking. Upper cutoff frequencies, if you take 20 to 44 band, whatever may be the value, lower limit is twice that of upper limit. Therefore, upper by lower always give you value of 2. Ratio will be 44 by 22 will become 2. Any bandwidth, lower is this, the twice of that will be upper. If he may ask you in this present exam, lower by upper ratio is half, 1/2, right? You must remember like that. This is what this is about octave band. Okay, look at this interesting question in air pollution, very easy question. If you can go through this question, which of the following is not considered as secondary pollutant? Which of the following is not considered as secondary pollutant? See, photochemical smog is secondary, pan is secondary, acid mist means acid rain. You can say mist is not rain, but I am saying acid rain is secondary. You can say mist also secondary. Carbon monoxide is not considered as secondary. These are all secondary pollutants, but carbon monoxide is not secondary, primary pollutant. You can take the value of option for this question is D. The next value. Okay, let me take primary and secondary pollutants list. You can also write easily. Primary we have oxides of sulfur, oxides of nitrogen, you have PM 2.5 and PM 10, and we have carbon monoxide CO, as well as we have volatile organic compounds which are also known as hydrocarbons. You can say HCs. These are all the list of primary pollutants. What are the secondary pollutants? We have ozone O3, we have photochemical smog, right? Photochemical. Have a quick recap of all secondary pollutants. Very important question. Many times they may ask you, even in GATE also, primary and secondary pollutants are asking. Okay, photochemical smog is the secondary pollutant, as well as acid rain also secondary pollutant. Any other just recall acid rain, and formaldehyde is also secondary pollutant. Any other things? We have peroxyacetyl nitrate, PAN is also secondary pollutant, right? These are all various secondary pollutants we have, right? This is the list. Okay, next question. Look at this. Precursors to the photochemical oxidants are, before forming a photochemical smog, what are the responsible pollutants which acts as a precursors? Before the photochemical smog formation, we have the list, that is oxides of nitrogen and volatile organic compounds or hydrocarbons. These nitrogen dioxide reacts with these hydrocarbons under the sunlight, it forms photochemical smog. Photochemical smog is a secondary pollutant, right? These are the precursors of photochemical oxidants. Okay, look at this. Which one of the following is not present in the acid rain? See, HNO3, nitric acid is acid, sulfuric acid is acid, carbonic acid is also acid. These are all strong acids. See, acetic acid is also acid, but which one of the following is not present in the acid rain? Acid rain occurs when the atmospheric pollutant reacts with the moisture present in the atmosphere, right? Whenever carbon dioxide reacts with H2O, H2CO3, sulfuric acid formed when sulfur dioxide pollutant reacts with the moisture, right? HNO3, nitrogen dioxide reacts with the moisture. Therefore, these are all present in the acid rain. These are all responsible for acid rain. This is nothing but acid rain, but the acetic acid is a weak acid which may not be absorbed in acid rain. That is what option D is the correct answer. Okay, the next question. See, these kind of questions from the air pollution is very common. They may ask you what are the health effects of certain air pollutants. Look at the sulfur dioxide and carbon monoxide adversely affect oxygen carrying capacity of the blood and functioning of lungs respectively. See, CO is functioning of the oxygen carrying capacity, it disrupts, right? Therefore, option A is not correct. Respectively, you need to take functioning of the respiratory system correct, but in brain damage, CO not brain damage. Functioning of the respiratory system and oxygen carrying capacity of the blood respectively. Therefore, SO2 and CO respectively impact this health. Health impact is this. Functioning of the air passage and chest respectively. No. Most appropriate answer is SO2 is respiratory illness, CO is oxygen carrying capacity to the oxygen carrying capacity of the blood is greatly reduced. Okay. Which of the following air pollution control devices has a maximum efficiency? You must be very careful. Out of the given list of devices in these options, you must look at, right? if you can look at the wet cyclone scrubber, spray tower, dynamic precipitator and ESP, electrostatic precipitator, out of which one is having the maximum efficiency? The maximum efficiency in the given list of devices is option D, right? ESP is the maximum device, maximum efficiency which can give. Okay, let me take this question. The air pollution control device cyclone is used for the removal of, what is the size of the particulate matter this device can be removed, that is what is asking. But this question is given, but that is not mm, it is wrongly given in that particular shift, but that is micrometer, not mm. You must take that is micrometer, not mm. Okay, but anyhow we cannot change that actual question asked in the RRB JE, right? You must take the values are correct, given mm is wrong, micrometer is correct. The cyclone separator, it can remove the minimum particle diameter is 10 mm, sorry 10 micrometer, right? Okay, let me have the quick revision with the help of various particulate control devices, its minimum particle diameter removed as well as efficiency. If you can look at the gravitational settling chamber, with the help of gravity means the particles which are having heavier than the fluid can be removed with the help of gravity alone, right? That is why we have the size of that impurity is more, 50 micron size is heavier size, that is gravitational settling chamber. The efficiency of the removal is 50%. Now we enhance that settling process and we can achieve further settling with a finer size with the help of centrifugal separator. The flue gas enters the device centrifugally, means it has the rotational effect. By rotating inside the tower, particle lose its velocity and it drifted towards the periphery of the device, that can be removed. That particle size is less, this is gravitational settling chamber is 50, half of that, remember 5 to 25 will be minimum dia it can remove, and the efficiency bit enhanced 50 to 90%, but the size is this only. But if you want much finer size, we must go for wet devices. These are all dry device, gravity settling chamber is a dry and centrifugal collector is also dry. The dry flue gas enters the device and removal happens, but in whenever the wet device come into the picture, this is the application of water inside the device. You can see wet scrubber or collector including spray tower is 10, as the question is given. Cyclone can remove means collector, cyclone collector, that is what cyclone collector, minimum is 10, efficiency is 80. Cyclone scrubber, which is efficiency is 80. Venturi scrubber, you all know what is venturi meter, right? Venturi meter as converging portion, throat portion and diverging portion. At the throat portion we have a water jet to capture the particle. At a throat the velocity will be very high but the pressure is less, right? As we study in a venturi meter, right, in fluid mechanics. Venturi scrubber removes the particles are finer in size, 0.5 microns, and its efficiency is less than 99%. See, the highest efficiency among all particulate control devices is venturi meter, not ESP, but in the given list in that question it has not mentioned venturi meter in the option, right? Therefore, venturi scrubber is 99. ESP, this is works on the electrical diffusion techniques, right? That is what size is less and the efficiency. You must understand here 99, it is also between this range, but size is very fine in the venturi scrubber. Therefore, highly efficiently removing particulate control devices is venturi scrubber, not ESP. Okay, this is a quick revision about these various control devices. Okay, next, see, you know, very easy question. At high temperature, the thermochemical decomposition of organic matter is happening. In the absence of oxygen is all known as pyrolysis, right? In the absence of oxygen is pyrolysis, right? In the presence is combustion, right? Okay, the next question, it is very easy. A coastal city produces MSW having high moisture. Look at the given things. It is having, I am writing the solution in a bit different way. What are the characteristics given in this given provided MSW? Its moisture content is high. Its moisture content is high. And it is having high organic material. Organic material I am indicating OM. Organic material is very high as you studied, organic material is having a least density, therefore organic material density is less, but in the given MSW we have more organic material. And another value, calorific value, right, calorific value is low, calorific value is less. These are all given properties I am writing, right. If organic matter in the given MSW is more, obviously inorganic matter is less, organic is more means inorganic is less. If you have more inorganic content, inorganic is having more density. Here I am writing inorganic is having more density, organic is having less density. These are all given parameters in the given MSW. Now what is asking, the most effective and sustainable option for MSW management in that city is, the most effective and sustainable option of MSW management is, see if you go for a landfill, what is happening with these characteristics of MSW. See, the given characteristics are the characteristics of an MSW. This is the given MSW. See what happens when you go for the final option, it's option D, landfill with these characteristics. See, it contains high moisture as well as high organic content. See, high organic material is having less density. If density is less, it occupies more space or less space. Think logically. See, if density is less, look at this. If density, as you all know, density equal to mass by volume. If mass by volume, if density is less, it needs more volume. It consumes more space. So that we cannot go for a landfilling when we have more organic load in our generated municipal solid waste. Therefore, more organic leads to lesser density leads to high volume of landfill. High volume means large area is needed. Therefore, landfill is not suitable for this management, MSW management. Go for an incineration. See, the calorific value of given waste is very less, incineration extract energy. If the calorific value of the waste is less, with incineration you cannot do anything, right. Incineration is also a bad choice for this given MSW management. Dumping in a sea, look at this option, dumping in a sea. If you simply dump your waste into municipal solid waste into sea without understanding the marine ecosystem, you cannot go for any dumping. It is the data provided here may not be sufficient to analyze whether we need to dump that waste into sea or not. We need more understanding about MSW to do this dumping in a sea, right. Marine ecosystem we cannot damage, right. Therefore, option C is wrong. Only one is composting. Composting is the correct answer. If you can look at, whenever the MSW is having the more moisture and more organic material, organic is biodegradable in nature, which is having high moisture also, so that we can convert that into useful manure for your fertilizer applications, right. Therefore, composting is the correct option, right, very easy. The next question, alum when mixed with water as a coagulant decreases pH or increases pH? Decreases pH. We studied why the moment you add alum to water, the reaction happened this. I have given this equation for you. See, alum is this aluminum sulfate. Alum generally consumes the natural alkalinity present in the water. If natural alkalinity is consumed by alum, the alkaline species are consumed. See this, HCO3 means bicarbonate. If alkaline species are consumed by alum, what happens? The pH is decreasing, alkalinity is consuming means acidic nature of the water increasing. By the way, this alum reaction also releases carbon dioxide here. The carbon dioxide imparts carbonic acidity to water. Hence, it is consuming alkaline species and releasing acidic species. It means it decreases pH. pH decreasing means acidity is increasing, right? You know pH scale. Less than 7 is acidic, more than 7 is alkaline. Therefore, with this simple important equation of alum coagulation, you can say alum coagulation decreases the pH and also impair non-carbonate hardness to water or permanent hardness to water. Look at this, calcium sulfate, the calcium magnesium in association with sulfate, chloride, nitrate impacts permanent hardness to water. Therefore, alum leads to permanent hardness as well as decreases the pH and effective in the range of 6.5 to 8.5. You must understand alum coagulation results. Okay, it is effective in this pH range 6.5 to 8.5 as well as it induces permanent hardness to water, non-carbonate hardness. It also decreases pH of water. According to the given chemical reaction, we can understand these three statements in much better way. Okay, this is about alum. We are not only covering only that question. With that help of the question, we are revising very basic concepts in that coagulation chapter also, right? Okay, look at this. You all studied about the filtration, right? Efficiency of removal of bacteria in slow sand filter up to an extent of, efficiency of removal is how much? Tell me. Efficiency of removal is, tell me, efficiency of removal of organic load or a bacteria in a slow sand filter. What is the efficiency of slow sand filter? As you all studied, efficiency of slow sand filter is nothing but, this is 98% to 99% efficient. Slow sand filter is highly efficient in removing organic load, but less efficient in removing color and turbidity, as you studied. What is the RSF, rapid sand filters efficiency, which is 80% to 90%. Here it is asking slow sand filter, that is 98 to 99%. Option D correct. Okay. Okay, now let me see how many of you are answering these questions. Okay, in villages, to disinfect the well water, the most common disinfectant used is, the most common disinfectant in rural wells is what? Potassium permanganate, that is KMNO4. You all studied KMNO4 is effectively used in disinfecting the rural wells, potassium permanganate, right? Okay, the next question. See, which of the following process includes chlorination of the water above the break point? As we studied the nature of chlorination curve, right? Above the break point, if you do excess amount of chlorine, that is not excess chlorination. Excess chlorination is not a type of chlorination, that is super chlorination. You don't do mistake here. If you add chlorine apart from the break point, leads to super chlorination, not excess chlorination, right? This is correct answer. Let me have a quick revision about the various types of chlorination. See, the types of chlorination means the stage at which chlorine is added and the way in which the chlorine is added. We have various types of chlorination. Look at the types of chlorination list. See, what is plain chlorination? The only chlorination is your treatment, then we call this as chlorination, plain chlorination. When can we go for this plain chlorination? We adopt this plain chlorination during the emergencies, right? If there is no time, at least we can do disinfection and supplying to the community, right? At war fields, we do plain chlorination. To supply water to our army troops, we do for at least we disinfect and supply to our army soldiers, right? Next, pre-chlorination means we do chlorination before filtration, that is what? Pre-chlorination. When can we adopt chlorination before filtration? The available source is of very bad quality, a very high organic load, then we need to treat before chlorination. If you apply that high organic load water directly onto the filter getting clogged and efficiency of the filtration process is disrupted. Therefore, we do pre-chlorination. Organic load is best removed by disinfection, right? It kills bacteria, viruses, right? Pre-chlorination means before filtration. Post-chlorination means chlorination after filtration. This is the this is the conventional method of treatment, right? Post-chlorination also known as chlorination. Chlorination after filtration. What is double chlorination? If you do pre-chlorination as well as post-chlorination, that is what double chlorination. It means you added, you did chlorination to that water twice, before and after. Since the available resource is very bad quality, you can go for a double chlorination. Means twice you did chlorination things, adding chlorine to water twice. What is super chlorination? Super chlorination means adding excess chlorine. Don't confuse this double chlorination and super chlorination. Double chlorination means the stage before filtration as well as after filtration we did chlorination is double, but super chlorination you did chlorination only once but added excess amount of chlorine. That is what the basic difference between this double and super. They are not same. Okay. Super chlorination means adding excess chlorine at only once, that is what super chlorination. What is dechlorination? If you add excess chlorine, you must ensure the extra safety, formation of trihalomethanes. You need to remove excess chlorine by dechlorinating. As you know, the dechlorinating agents, right? See, the dechlorination can be done with the help of sulfur dioxide and activated carbon. I am simply writing here activated carbon. A carbon means activated carbon, and hypo, sodium thiosulfate you can write. These are all dechlorinating agents. That is what dechlorination means. You know, breakpoint chlorination, we conducted the test. We are adding the dose of chlorine, and we will see the residual amount of chlorine left in water. But this breakpoint chlorination gives the point at which the chlorine demand has been totally satisfied. Chlorine, you know, chlorine curve you studied, chlorine first meets its demand, right? Consuming reducing substances, then formation of chloramines, destruction of chloramines, and then the additional amount is shown as residual chlorine. Okay, this is all about plain chlorination. These are very important things to revise the entire environmental engineering, right? Okay, next, zero hardness of water is achieved by, the zero hardness of water is achieved by what? See, the given list, all the methods of all the methods given in these options are reducing hardness of water. Lime soda reduces hardness, boiling also reduces carbonate hardness from water, using excess lime also removes hardness from water, but zero hardness means the complete removal of hardness can be achieved only by zeolite method, that is ion exchange method. This is what? Complete removal of hardness. You may not find even a single I mean 0 milligram per liter is hardness, no hardness at all, that is achieved by ion exchange or zeolite method. Okay, this is about zero hardness. See, the type of valve which allows water to flow in one single direction but prevents the back flow, reverse flow, which is what is that kind of valve? That is sluice valve, right? The type of valve which allows water in one single direction but it prevents the reverse prevents its flow in the reverse direction is what? Reflux valve, right? See, if you can quickly recall, this is what? Reflux valve, non-return valve or a check valve. If the water flows through this valve, it does not allow backflow of water. Once it passes through this joint, this pivot will have an hinge action. Water passes through this joint very easily, but there is no reverse flow. This flow cannot be allowed. By this flow, it will be closed, not allowed backflow. This is what? Reflux valve, non-return. Once the water enters this, no return. That is what? Non-return valve. Check valve, it checks this reverse flow. That is why it is check valve. This is about non-return or check valve. It allows water in one single direction. Look at this sluice valve. This is also known as gate valve. It regulates the flow. This is also known as gate valve. It also regulates the flow. With the help of this sluice, we can control the flow with the help of this valve. If this valve removes, this valve prevents the pipe, air valve or air relief valve prevents the pipe from negative pressures. If there is a building of negative pressure inside the pipe, air is relieved and negative pressure can be controlled effectively with this valve. Another valve is relief or pressure relief valve. This pressure relief valve is provided to prevent the pipe from bursting. Any hydro water hammer pressures, if you can experience in the pipes, these pressure relief valves can help you to prevent the pipes from bursting due to water hammer, right? These are all various kinds of valves. See, this is very easy question. It may seems to be very lengthy. If you can look at BOD determination of a sewage, initial DO is 8.3. After 20 degrees centigrade 5 days incubation, it is found to be 2.3. The dilution factor is 1:60, means 60 times getting diluted. What is the BOD5? You already know, initial DO minus final DO. I am not writing the formula. 8.3 minus 2.3. Initial DO minus final DO means DO consumed into dilution factor is 60. That is 6 into 60, 360 milligram per liter is the answer. Simple question based on the BOD. You may get simple straightforward questions from this BOD chapter. Next, which of the following expressions are the correct about oxygen demand? If you can look at these options carefully, COD is more than BOD. You may tick this option and go to the next question. That is the wrong answer. See, if you can look at this question carefully, what is given here, which is the correct expression about the oxygen demand. You know, COD is obviously more than BOD. If it is more than BOD, COD is not equal to BOD. That is the small logic behind it. Once asked in the gate, right? The COD is more than BOD. It means A correct, B correct. Both A and B is the correct answer, right? You all know theoretical oxygen demand is more than COD and then BOD. That is the order of oxygen demand, right? This is about this question. Very easy. Don't be in a hurry and tick this option and leave the go on to the next question. Be careful in these kind of questions. Okay. The next question is, Imhoff cone is used to measure. Imhoff cone is used. You all know settlable solids. Imhoff cone is used. Next, in case public drainage system is not available in a locality, then the structure used to store wastewater from the toilets is the structure which is used for a natural the structure used to store wastewater from the toilet is what? Septic tank, not sump. Sump is different, right? Sump we can store good water also, right? The septic tank stores wastewater. See, as we studied about septic tank, when there is no natural drainage system in the rural areas, every house can have this septic tank, right? Next, the detention time adopted for grit chamber is of order. The detention time of a grit chamber is how much? 1 to 3 minutes, just 1 to 3 minutes. All the settled grit we can experience at the bottom of the grit channel, right? Okay, look at the list of detention times and a unit of treatment. Very easy to recall this. Plain sedimentation in water, right? Plain sedimentation is 4 to 8 hours. If you enhance the plain sedimentation with the help of coagulation, sedimentation aided with coagulation is 2 to 4. 4 to 8 becomes 2 to 4 with coagulation support. Grit is 1 to 3, 2 minute or 3 minute. Septic tank is having 12 to 36 hours detention time. Oxidation pond is a long detention time. We are dependent purely on the natural process of decomposition. That's why it is taking longer time, more than 3 months sometimes. The large area we apply whole wastewater of a community, just leave for some time. That is more detention time. In the given list of treatments, oxidation pond is having the long detention time. Sometimes they may ask you which of the treatment is having long detention time, that is oxidation pond. PST, primary settling tank, in the waste treatment 1 to 2 hours is detention time, right? This is about various units. Okay, a septic tank is a settling tank as well as digestion tank, both A and B. Don't confuse here. A septic means in the septic tank settling happens, but at the bottom sludge at the bottom of the tank sludge is accumulated. There you can see digestion of the settled sludge. Therefore, both A and B can happen in a septic tank, right? Okay, the next one. See, I am providing this list of types of settling and observed in entire environmental engineering. We can experience these types of settlings. You can look at the discrete settling. Where can you observe this discrete settling? Discrete settling in a dilute suspension can be observed in plain sedimentation. Flocculent settling, let me list out what are the various settlings, right? Type 1, type 2, type 3, type 4. 4 types of settlings we can experience in the environmental engineering. Discrete observed in plain sedimentation. What is the flocculent settling? Observed in sedimentation aided with coagulation. Flocculent particle settling in a dilute suspension. What is discrete particle? Particle's characteristic does not change with time. Its size, shape remains same. Flocculent particles size and shape is changing with time. That is what flocculent settling, right? Now, zone or hindered settling. Where can we observe this zone or hindered settling? In a wastewater engineering, we may studied the unit which is following the ASP. What is the unit which follows activated sludge process? Secondary settling tank. In that secondary settling tank, the concentration of impurities is very, very high. Therefore, such a high concentration, the particles keep hindering with each other. Due to the hindrances, what happens is each and every particle attains the constant velocity. That with that constant velocity, as a zone, the particle settling happens. That is what zone or hindered settling, which is happened in SST, means secondary settling tank. After the, you know, right, you studied this is the ASP. after this we connect this to secondary settling tank like this, right. This is what we studied. In this secondary settling tank, in this SST we can experience that hindered settling. Since the concentration is very high, the particle hindrances will happen. Due to those hindrances, these particles at the same horizontal level attains the same speed, so that the whole particle at that horizontal level settle down with the same speed. That is what zone settling or hindered settling. Due to hindrances, it leads to zone settling. Now, compression settling, where you can observe at the bottom sludge deposition happens, right, at this bottom. Now, bottom of SST following ASP, trickling filter and sludge thickening, you can observe compression settling, right. See, once the settling of these particles happen, the particles that solid settling further happens by squeezing out of water. That is what compression. This layer applies compressive force on the layer which is below. Therefore, whole layers applied compressive forces, moisture in that layer is squeezing out due to applied compression, that is observed in bottom of SSD following ASP or trickling filter. We must say either this is an ASP secondary treatment or trickling filter. You can have trickling filter. After that, the unit is SST. At the bottom you can experience this compression settling, or else sludge thickening we can experience this compression settling. Okay. With this we covered almost all the concepts of environmental engineering. I hope this session somehow helps you a lot to revise the various concepts of environmental engineering. I hope that I have taken the questions in such a way that the entire environmental engineering is revised in this 1.5 hour sessions, right. I wish you all the best for your CBT-II exam. Thank you.